Welcome back, dear friends. I hope you all are good. Now, see here, we completed now only whatever acids part in that all reactions of acids, preparations of acids, physical properties, chemical properties of acids, then uses of acids. Now it's time to move further. Okay, so that is our next part. So next part here, bases. What beta here? Bases. Okay. So we are continue our next part, that is bases. So as you know bases. So here I am sharing with some bases examples. Okay. Say your caustic soda, NaOH. Okay. Then caustic potash. Then your sodium carbonate, Na2CO3. Okay. So these are what examples of your, yes, examples of your bases. So this Na2CO3 we can call it as a what, washing soda. Okay. Then a quicklime. Okay. So see here quicklime. Then your slacklime, CaOH twice. So these are what examples of bases. So these bases, as you know, how they are slippery in touch, bitter in taste. Okay, and almost all these bases, what they are doing? Yes, almost all these bases changes color of litmus from red to blue. Okay, so these are some basic property here. Understood? So generally all these are bases when their aqueous solution, what they are giving us? Yes, they are producing hydroxyl ions. What they are producing? Hydroxyl ion, OH minus. We call it as a what? Yes, hydroxide ion, or what we call here? Yes, hydroxyl ion. Okay, this OH minus. So this OH minus, what they are showing? Your compound is what, beta? Basic in nature. Okay, so whatever that base is, that base is, yes, your metallic oxide. Okay, that base is your metallic oxide or metallic hydroxide also. Understood? And generally what? Metallic oxide, these are what? Bases. Metallic hydroxide also bases, no doubt. Understood? So we will see here some uh, normal or basic reactions here about your what? Basic oxide. Okay, so see your basic oxide. Suppose if you are thinking about basic oxide, so oxide means what? Yes, O2 minus, like this. Basic oxide. Okay, so when it will react with acid, so what will happen? Yes, salt plus water. So like this reaction, say basic oxide Na2, this what beta, sodium oxide plus H2SO4. Yes, plus H2SO4. What they are giving us? Yes, they are giving us Na2SO4 plus H2O. Understood? Okay, so these are metallic oxide, or we can say basic oxide. Understood? So like that, but a basic hydroxide also there. So when your basic hydroxide like this, see here, your NaOH, basic hydroxide plus H2SO4. Now only we saw the reaction. So reaction, what you will get here? Yes, you will get Na2SO4 plus H2O. But in previous lecture we saw the temperature difference above, below 200 degrees Celsius, what? Sodium bisulfate you will get, and above 200 degrees Celsius you will get what? Na2SO4. Okay. So these are simply reaction, and you can balance also. Yes, 2Na. Okay, so here what beta here? 2H2. Our reaction is balance. Okay, so these are regarding what beta? Basic oxides. So generally you keep in mind one thing, in bases. So we saw here basis part. Okay. So one thing here, keep in mind, all alkalis, yes, all alkalis are bases, but all bases, all bases are not alkali. So beta, generally alkali is what? That basis, it forms basis on dissolving in water. Okay, basis means what? What is the possibility or what is the condition of alkali here? That base, it must be dissolved in water. Then and then only we call it the what? It is alkali, soluble. So some like that basis also there. It is what beta? Insoluble. So see that insoluble. Okay. So in that examples, insoluble bases, ferric hydroxide. Okay, ferric hydroxide. Yes, formula as like this. Formula beta as like this. See, FeOH thrice. Okay, then your copper hydroxide. Yes, copper hydroxide. Copper hydroxide as like this, CuOH twice. Understood? Whatever these bases are not alkalis. These bases are not alkalis. Why these bases are not alkalis? Because it is insoluble in water. Okay. Understood? Now we will move towards next, that is classification of bases. What better here? Classification of bases. Okay. Now see here, we will start classification of bases. Okay. See, classification of bases. So in classification of bases here, if you are we will write here like this, bases. Okay, so like this. Now see here what will happen and how classified, how it will classified. Okay, so depending on strength, first is what beta? Yes, depending on strength. Understood? So depending on strength, what we call? Yes, strong bases. Yes, strong bases. And what beta here? Weak bases. Weak bases. Strong bases, weak bases. Now depending on concentration, what we call this bases? Depending on concentration. Yes, weak. No, how weak it is here? Yes, depending on concentration, what we call? Yes, dilute. Okay, dilute. Yes, beta, dilute bases. And what? Yes, concentrated bases. Dilute bases and concentrated bases. And depending on acidity, how we can classify depending on acidity? Yes, first one we call it the what? Monoacidic base. Yes, monoacidic base. Then second what? Diacidic base. And third one what we call? Yes, triacidic base. Okay, so these are what? Classification of bases. Understood? Now we will move towards in detail, in depth of that. With an example we will discuss here. So depending on strength. So ready with this? So see here, depending on strength, how we can call depending on strength? Yes, strong basis. Yes, first is what beta? Strong basis. So on the basis of what we call this the strong basis? Yes, that basis it is completely ionized in water and having high concentration of what? OH minus ion. Yes, completely. Okay, see here, completely ionized. Completely ionized in water and what beta? High concentration of what? OH minus ion. Understood? So strong basis, see example NaOH aqueous. So what you will get here? Yes, Na plus aqueous plus what? OH minus aqueous. These are example of strong base NaOH, KOH. Okay, and suppose if you are considering here weak base. So weak base is what? Yes, these are completely ionized. So weak basis is what beta here? Partially ionized. Yes, partially ionized in water. Okay, and what beta here? Less concentration of OH minus in that basis. So examples here beta, example we will write. Okay, so say NH4OH aqueous. So what you will get? Yes, you will get NH4 plus aqueous. What beta here? These are what? 4. NH4 plus aqueous plus what? OH minus aqueous. These are weak base. So why we call this weak base? Because it is partially or incompletely ionized in water. Another we can write here beta barium hydroxide aqueous. So barium hydroxide aqueous, how we can write? Ba2 plus aqueous plus what? 2OH minus aqueous. Understood? Okay, so these are what beta? Depending on strength, strong basis, weak basis. Okay, so now we will move towards our second classification. So that depending on concentration, what beta here? Yes, depending on concentration. So depending on concentration, how we can say that? So in small a, how we can say that depending on concentration? So concentrated base. So concentrated base, what we can write here? Concentrated base. In concentrated base, high amount of base is present. Okay, high amount of base is present. Say here, when high amount of base is present in a fixed amount of solution. Fixed amount of solution. And suppose if you are writing about dilute basis, so what we can write dilute basis? So beta, you have to write in your notebook So what we can write about the dilute bases? Yes, dilute bases beta when less amount of base present in fixed amount of solution. What beta here? Less amount of base is present. Okay, so these are what beta here? Second year classification of bases. Understood? High amount and less amount, but in fixed amount of solution. That is important. Okay, that is important. Now we will say third, depending on, yes, depending on acidity. And as you know, we discussed beta base. We are discussing base acidity and acid basicity. Okay, so see here, depending on acidity, so we further divided small a what beta monoacidic, yes, monoacidic bases. So in monoacidic bases, as you know, so beta generally acidity, how we can, number of replaceable OH minus ions or number of replaceable hydroxide ion, that acidity we can we can refer on the basis of number of replaceable OH minus ion or hydroxyl ion. Okay, so in monoacidic bases, so what we can call this here, that bases they are producing only one hydroxide ion per molecule. Okay, so one hydroxide per molecule they are giving, means what, on dissociation with water. Example what beta here? Yes, KOH, NaOH, only one OH minus they are giving. Suppose if you are thinking about aqueous solution of KOH, so what? K plus aqueous plus this OH minus aqueous. So beta here one only OH minus per molecule on dissolving in water. Okay, so these are example what beta, small a monoacidic bases. Suppose if you are writing small b, yes, small b what, diacidic bases. So diacidic bases is what? Yes, diacidic bases, they are giving or they are replacing 2H minus ion, 2H minus ion on dissolving water per molecule. Okay, so examples. So see here examples, as you know, magnesium hydroxide, MgOH twice, aqueous solution, what they are giving us? Yes, Mg2 plus what beta, 2OH minus, aqueous, and here also aqueous. And example we can write one more here, yes, diacidic bases, calcium hydroxide. Okay, so these are what beta here, examples of monoacidic and diacidic bases. Suppose if you are thinking about small c, that is triacidic bases. So triacidic bases, they are producing what? They are producing 3 OH minus ion per molecule on dissolving in water. Beta, whatever I am saying, you have to write in your notebook. Okay, understood? And make notes. Okay, so triacidic bases, you see here, it has or it contains 3 hydroxyl groups. Understood? So examples, we can write here examples. Yes, ferric hydroxide. Ferric means what? 3. Ferric means what? Fe3 plus ion, 3 OH minus, Fe3 crisscross method. So how it dissociated? Yes, Fe3 plus 3 OH minus These are also in aqueous. Here also aqueous. Yes, aqueous. Understood? So these are examples triacidic bases. Okay. Now we will discuss here preparations of bases. What better here? Preparations of bases. So concentrate on this also. In triacidic bases, you can write example aluminum hydroxide also. As beta, you know what is the formula of what? Yes, formula of here aluminum hydroxide, it is ALOH thrice. Now we will discuss what beta? Yes, preparation. Yes, preparation of bases. So first here preparation of bases by the action of water on reactive metals. Okay, see here by the action of water on reactive metals. So which these are reactive metals? Yes, calcium, sodium, potassium. These are what? Yes, examples are what? Calcium, potassium, sodium. These are what examples of active metals, reactive metals. So see here, example calcium solid plus water. So what they are giving us? Yes, what they are giving us? Calcium plus water. By the action of water on reactive metals, you will get what? Base along with the hydrogen gas. So you have to balance this reaction. Take here 2. Yes, our reaction is balanced. Okay. These are in aqueous. These are what? Gaseous. Understood? So you can complete. You have to complete this reaction with potassium. Can you? Yes, KOH plus H2. So for balancing, yes, our reaction is balanced. 2K, yes, now our reaction is balanced or not. See, 2K, yes, here 2 not will come, beta. Okay, say 2K, 2 oxygens are there. Okay, so see here 2K, 2 hydrogen, 4 hydrogen, yes, 4 hydrogen now complete. Understood? So see once again 2 potassium, 4 hydrogen, yes, 4 hydrogen and 2 oxygen, yes, our reaction is balanced. So here balancing also very much important beta. Okay, so by the action of water on reaction on reactive metals. Okay, so whatever our next reactions that we will discuss in next lecture. I hope you understood all. Okay, so take care, stay safe and stay home. Thank you.